Hi, and welcome back, Border High, to Part 2 of Unit 4's Chemistry Notes. We are continuing to look at Objective C6A. You're going to understand experimental design and conclusions used in the development of the modern atomic theory, including Dalton, Thomson, Rutherford, and Bohr's experiments. We're also looking at C3F, Research and Describe the History of Chemistry and Contributions of Scientists. C6D, Use isotopic composition to calculate average atomic mass of an element. We are talking about atomic structure now. First of all, the atom. We mentioned a little bit about the history behind the atom in the last video. The atom is the smallest unit of an element that has all the properties of that element. Okay? By properties, we're just talking about physical and chemical characteristics. They're all present at that atom level. Atoms can exist alone. Remember in the last unit we talked about the difference between pure substances versus mixtures. Pure substance, you can either have an element, which would be an atom of a certain kind alone. You can also have compounds where you have two or more atoms joined together chemically. They are made up of, at the level that we're going to be studying anyway, protons and neutrons in the nucleus and electrons whirling around the outside. Okay, a Frenchman named Henri Becquerel, I think that's how you say that, discovered radiation. And so he found out that one of those tenets of the atomic theory that Dalton came up with about atoms not being breakable was incorrect, that atoms can be divided. He found out that radiation, which was caused by those atoms falling apart, existed. Okay, now you only do this to Miss Howard. You're not supposed to do this to me. That's not fair. Okay, Joseph John Thomson did experiments with cathode ray tubes, and basically he discovered something which was a stream of particles which seemed to come from the cathode, which is this part down here, and flow toward the anode, which is this part right here. And these tiny particles were able to impart force. They were found in pretty much any element that he tested this with, and they could be deflected with the use of a magnetic or an electric field. Okay? These later came to be called electrons. It has on here computer monitor. Most computer monitors anymore are LCD, and so this is no longer true. In fact, we're having a hard time anymore coming up with modern examples of cathode rays or cathode ray tubes, because anymore TVs aren't made like they used to be made. I'm sorry, I'm being juvenile here. Okay, well, if you're in pre-AP chemistry, which none of my guys are, you're going to need to know the setup of that experiment. Let's talk some about electrons. So an electron is ridiculously lightweight. They are so small, their total mass, if you're totaling them up, hardly comes to anything measurable. So for all intents and purposes, we don't consider them to really have any measurable mass. They are negatively charged. That's very, very important. They exist somewhere between the nucleus of the atom and the edge of that atom's atomic radius, how far out it comes. Like I said, the mass is very, very tiny. Now, even though it's very tiny, its charge is equal to the charge from a proton, except that a proton has a positive electric charge, this has a negative electric charge. And all electrons are alike. Okay? There's no such thing as a gold electron or a carbon electron or a phosphorus electron. An electron is an electron is an electron. Thomson's model of the atom basically showed that there were electrons somewhere present in the atom, but he didn't really have any kind of structure beyond that. There wasn't really much to know. This is referred to, and this may come up on a slide here in a minute, as the plum pudding model of the atom. Let me see if I can write here. Doubt it. No. which I don't know why we even continue to still teach plum pudding unless you happen to be in Great Britain. We don't eat much plum pudding around here, at least I've never had any. If you've ever had some, let me know. If you want to make me some for extra credit, I'd be fine with that too. A scientist named Niels Bohr later on postulated that electrons have to orbit the nucleus. This is referred to sometimes as the planetary model of the atom. The reason it's named that is because he has electrons orbiting the nucleus, much like planets orbit a star, like the sun. There were a lot of problems with his model. For one thing, his model only held true for atoms that had one electron. If you had any atoms with two or more electrons, there were some problems with energy and radiation present in his atom. And I'm really not a particle physicist, so I don't want to get too deep into the physics involved there. That's Niels right there. The oil drop experiment. Again, if you're in my class, you've seen a video on this already. They took fine droplets of oil and sprayed them in between two metal plates. And gravity was pulling down on the oil droplet, and they had X-rays bombarding the chamber where the oil was to give them an electric charge. And then what they did is they charged the top plate with electricity, and they were able to actually suspend the oil droplets halfway between the two plates. And when they got them floating just perfectly, they measured the amount of electricity on that upper plate, and they were able to use that to determine what the electric charge on those oil drops was. And they found that it always came in multiples of this right here, 1.602 times 10 to the negative 19 coulombs. Okay, you don't really need to memorize that. And they were able to then figure out that that's the charge of the electron, and using information that they had from the cathode ray experiments, they were then able to use that charge to calculate the mass of the electrons. And so they then found out that we're talking a very, very, very tiny particle with a fixed charge. Okay. I think this is in a previous slide, actually, so I'm not going to spend too much more time on it. Okay. Again, if you're not in my pre-AP Chem class, then this doesn't do much good for you. If you are in Miss Howard's class, what are you doing watching me? She's your teacher. She does a much better job at it. Go find her stuff. Go away. And that's the end of this show.